Hello everyone, welcome to my YouTube channel. In this video, we will learn how to solve the Fibonacci number series problem by using dynamic programming. First, let me explain to you what is a Fibonacci number. Fibonacci sequence is a sequence where the first two terms are 0 and 1 and the next terms are obtained by adding the previous two numbers. For example, we have 0 and 1 as the first two numbers. We add these two numbers, we get 1. We get 1 with 1, we get 2. We get 1 with 2, we get 3. We get 2 add up with 3, we get 5. We add 3 with 5, we get 8. And the list goes on up to infinity. So we can see that we are just adding the previous two numbers to get the next possible numbers. And this is the Fibonacci series. We can always solve this problem recursively. In this recursive function Fibonacci function, we have Fibonacci of 0 and Fibonacci of 1 as the base case, and if we get n equals to less than or equals to 1, we will return n, or else we will calculate the Fibonacci of previous two numbers recursively, and this is how we will get the recursive solution. If we form a tree of this problem and try to solve it according to the recursive function, to get Fibonacci of 6, we need Fibonacci of 5 and 4. For Fibonacci of 5, we need Fibonacci of 4 and 3. And in the end, we will get our base case of 1 and 0. And by returning the value, we will get the accurate value of Fibonacci of 6. If we notice carefully, we will see we are calculating some sub-problems repeatedly. For example, Fibonacci of 2, Fibonacci of 3, Fibonacci of 4 are being calculated multiple times. So, why do we need dynamic approach if we get a perfect answer by recursive formula? What is the problem with the recursive solution? Well, the answer is time complexity and these overlapping subproblems. As we can see, we need Fibonacci of 2 multiple times in the tree. Also on the left side of the tree, we are expanding the branch by n times. And on the right side, we are expanding the tree by n by 2. Like left side, we are going Fibonacci of 6, Fibonacci of 5, Fibonacci of 4, and this goes on. And the right side, we are going Fibonacci of 6, Fibonacci of 4, Fibonacci of 2, then the list goes on. So we can see that the time complexity will be between 2 to the power n by 2 and 2 to the power n. In the worst case, the time complexity would be 2 to the power n, which is exponential. To improve this scenario, dynamic approach comes to the rescue. There are two versions of dynamic solutions, memorized version and the iterative version. First, let me explain you the memorized version. For example, if we want to calculate Fibonacci of 4, let's take an array starting with 0 to 4. Initially we will make all the values minus 1. Now the approach would be, if we get minus 1, the index will expand. For example, we have Fibonacci of 4 is minus 1, we will expand. Then we have Fibonacci of 3, which is minus 1, we will expand. We have Fibonacci of 2 is minus 1, we will expand. And finally we get the base case, which is Fibonacci of 1 and Fibonacci of 0. And we know what is the base case in this scenario, which is Fibonacci of 1 equals to 1, Fibonacci of 0 equals to 0. Now we update the table, and now we have the value of Fibonacci of 1, and it will result Fibonacci of 1 and Fibonacci of 0 will result Fibonacci of 2. So we will update the table. and we already have the value of Fibonacci of 1, so we take this as the value, and to calculate Fibonacci of 3 we add up these two Fibonacci numbers and we get the Fibonacci of 3, which is 2, and we will update the table. Fibonacci of 3 is 2. Now the interesting part is we have Fibonacci of 2 in the table, so we don't have to calculate this part, expand this part again and again. So we can take this value Fibonacci of 2 from this array. So we have Fibonacci of 2, which is 1, and by this we get the Fibonacci of 4 equals to 3, and we update the table. So the time complexity we get is big O of n plus 1 equals to big O of n, which is linear. How we are getting this time complexity? Well, we can see that Fibonacci of 4 is getting Fibonacci of 3, 2, 1 and 0. We are calculating this part n plus 1 times, so we get the time complexity big O of n plus 1, which is big O of n. You can see we are getting a time complexity of linear big O of n, which is far better than the exponential. And here is the code of memorized version. I hope you can easily understand it now, as we are taking the base case at Fibonacci of 0 equals to 0, Fibonacci of 1 equals to 1, and we are calculating rest of the values to -1, and we are using this function Fibonacci of n not equals to, if the Fibonacci of n is not equals to -1, we will return this value, or else we will use the previous two numbers Fibonacci recursively. Now, what if we can make the memorized version more efficient? For this, we have this iterative version. In this version, we go from bottom to top. Firstly, we initialize the base case for 0 and 1, and for the next value, we take help of the previous two indexes. Add the previous two and update the next. That's the approach here. By adding 0 and 1, we get the next value 2, which is 1. The same way, we update the Fibonacci of 3, and finally we get the Fibonacci of 4, which is 3. If we try to find the time complexity now, we can see the time we are updating table. This time we are just updating a table of n size, so the time complexity would be big O of n. This is how we can calculate the Fibonacci series by using dynamic programming. Thank you for watching.